Hi and welcome to presentation of Hadoop Feature Density tool, which is an open source tool for big spatial data analytics, and it is based on GIS tools for Hadoop. Now, what are GIS tools for Hadoop? GIS tools for Hadoop are essentially a suite of tools, open source, that allow users to create Hadoop-based geoprocessing applications. There are three components. The first one is ESRI Geometry API for Java. The second component is Spatial Framework for Hadoop itself, which basically contains some utilities for interconversion to JSON, and also you can define your Hive UDFs there, um, and use existing user-defined functions for geoprocessing. Geoprocessing tools for Hadoop. The third component is essentially a bridge between ArcGIS desktop or ArcGIS server and HDFS. Now let's start with an introduction to the environment. I'm currently using Cloudera CDH. So let's have a look. So the current version that I'm using is Hadoop 2.5.0 and the CDH version is 5.3.3. So the first thing is to actually go to the workspace. In this case, I have copied to my workspace feature density. So I'm assuming that you've downloaded feature density source code, or you have cloned the GitHub repository. So let's have a look at what do we have inside. So as you can see, there is a POM file. It is a Maven based project. If you look at the structure of Maven, you will see it's not very clear, but there are a number of dependencies, including ESRI Geometry API, and it also uses Spatial SDK Hadoop. So the first thing that we would do is go to the libs directory and see this is Spatial SDK Hadoop by ESRI. Now we need to install this jar to local Maven repository. So the command is, I've just copied it for so standard Maven command to install a local jar file. So we're just giving the file name, the group ID, the artifact ID, and the version 1.1.1, and the packaging is jar. So this would install Spatial SDK Hadoop jar in local Maven repository. Next we go back to the root of Hadoop Feature Density tool and Maven install. So we have to wait a bit for Maven to download all the dependencies. The first time it is slightly slower. Now it has compiled and built with dependencies the feature density application. Now let me briefly explain what it does. So Hadoop feature density application is, as I mentioned earlier, based on GIS tools for Hadoop. The intention of this tool is to allow users to create thematic maps based on feature density. So what it does essentially is that if you've got some point data and you've got some polygon data, you can check for point and polygon test, and then you can aggregate all the features in a polygon based on some criteria. which in this case is that the point falls within the polygon, then it is considered a hit, otherwise it's a miss. And then we would be generating the once the Hadoop job would run, we would generate a choropleth map out of it, and I'll explain how we'll do that. First thing first, we need to get access to some data. So I have copied some data. So if you see, we have a data directory. So the requirement is, let's go. So there is points data and there is polygons data directories. Let's go to points. Now if I don't have any data here, so the first requirement is to get some point data. So I have some sample data over here, subset. Let's copy, and the file name should be exactly points.csv. Now if I look at points.csv, that basically is data that I downloaded from OpenStreetMaps and I converted it into CSV. So you can see that it has X, Y, Z and all the longitude and latitude, and so probably if you see there is a header there, X, Y and Z are good, when you convert it, when you convert OpenStreetMaps into data which is OSM or protocol buffer format into points data, you use a utility called OSM convert. So OSM convert you can download and compile using wget. It would compile, and then you can use OSM convert, name of the OSM file that you've downloaded earlier, maximum objects, and then what would be the structure of the CSV. And then we're dropping ways because we don't want ways and relations, and CSV separator is comma, otherwise it would use space. So I'm assuming that we have downloaded the data, we've done this. So moving on to the next step, we have to remove the first line. So it would be, we're using stream editor, in place editing 1D and points.csv. Now if we check, voila, it doesn't contain the first header file, header line. Similarly, if we go to polygons, I have some polygon data in GeoJSON format. Again, it should be named exactly polygons.json. So Hadoop feature density tool, at least the present version, expects that the points and polygons data are, the nomenclature should be that polygons should be stored as polygons.json and points data should be points.csv in respective folders. And next we've got, let's go back. There is a script here called FeatureDensity, and now what we want to do is run this script. So if you just run this script, let's see what happens. So it would basically give the usage. So the usage is that you give the name of the script and then the key attribute on which you are going to aggregate the points, then the index of longitude, and then the index of latitude. If you want to do some filtering, filter column index and the filter text. As an example, let's have a look at the field name. We have to select the field name on which we are going to aggregate. So if I do more data polygons.json, you would see that there is an SLA underscore name 11 which contains the name of the statistical local area. So we'll use that. And now similarly, if we do again points.cv, you will see that the longitude is the first column, the latitude is the second column. So as per our requirement, it would be, the command would become feature density SLA name 11 first column, second column, and the next two -1 and -1 because we are not going to do any attribute based filtering. Let's run it. So the script would create HDFS directories, and it would copy the point and polygon data to HDFS, and then it would launch the MapReduce job. So now you can see the MapReduce is running. Because I'm using local CDH VM, it just has one master and one worker. Now the job is finished. Now if we look, the last statement here is a help, an indication of what do we need to do to launch the dashboard. So we need to copy this command. Let's copy this command and paste it. And it has launched our interactive mapping application, which we're calling FeatureDensity Dashboard. So if you zoom in, so what it has done is it has computed feature density based on the area, so the feature count divided by the geographic area. Then it has basically created equal interval classes and then assigned each of the polygon to a particular class. So if we zoom in, you will see that we can see some dark colors. So these dark colors are where the density of the features is high. So if I click, so I see that there are 128 features in this polygon. This is the feature, but the feature density is high, probably highest, because the area is small. So this tool we can use in several different ways. For instance, you can download OpenStreetMap data, which has lots of tags, and then you can filter based on those tags. For instance, if you want to know the highest density of hotels or the highest density of hospitals, these sort of things. The tool is still in infantile stages, but I hope that gradually we can improve it in the open source community. That's it for the time being, and I hope that you would enjoy using this tool. By the way, I would like to draw your attention to another site which is called geofabric.de, I guess. Yeah, no. Let's search geofabric. So you can download OpenStreetMap data from geofabric.de. They've got subsets for Australia, for other North America, for different regions. Instead of downloading planet.osm, which is huge, 40 GB uncompressed at the top, compressed at present. Um, so that's it. I hope you like the tool. Thank you.